PBR Working Group is a function of the Center for Partnerships and Innovation at NARUC, and is especially for commissioners and staff to better understand PBR. Another special thanks to the U.S. Department of Energy for their ongoing support, and all the public materials are posted on the NARUC CPI website, particularly the evaluation rate making section. Next, I would like to introduce the Honorable Michael Richard. He is a commissioner at the Maryland Public Service Commission. He has extensive experience in and out of state government, but has been a commissioner since 2016. And I would like to welcome him today to set the tone for the PIMs for Resilience webinar. Commissioner Richard.
Thank you, Carrie. Thank you very much. And I really appreciate the opportunity to be with you this afternoon. Thanks for the invitation. And good afternoon from an incredibly gorgeous day in Baltimore. It's unseasonably nice. Today's topic is of particular interest to me and is really timely to my state. Currently at the Maryland Commission, we are actively engaged on separate initiatives for both performance incentive mechanisms and on grid resiliency to understand what resilience means, how to value it, and how it advances reliability. Our commission recently initiated a multi-year rate-making pilot, and one of the public interest benefits we found for multi-year rate plans is that they work well and in tandem with performance incentive mechanisms. We are in the very early stages of the PIMs development process, and see PIMs as a great way to advance some of our various state policies. So in today's discussion, I'm really interested to learn why resiliency is a system benefit that we should consider advancing with PIMs. Like many states, we already require specific and high-level system performance using metrics like SAIDI and SAIFI. Why not just do the same for resiliency? And on resiliency, we also just initiated a distribution system planning work group based on the recent NARUC-NASIO Comprehensive Electricity Planning Task Force, which I believe is also supported by the Department of Energy. And system resiliency is one of the named objectives for our work group. And I believe Dave Littell will be talking a little bit today about Maryland's energy storage pilot program, which also is a system resiliency, has system resiliency as one of its objectives. So again, I'm very excited by today's topic, and I expect to learn a lot from our outstanding panelists who all have both expertise and experience with the topic of combining PIMs with system resilience. And our very first presenter will be Dr. Mark Lowry. Dr. Lowry holds a PhD in applied economics from the University of Madison, Wisconsin. He is the author of numerous reports, including two reports, recent reports with the Lawrence Berkeley National Laboratory on how PBRs can play a role in regulating the electric utility of the future. And he has experience with states and Canadian provinces. Mark will lead us through considerations for resilience and determining if a PIM is the right PBR approach for your state. Dr. Lowry, please.
Thank you for that nice introduction. And we can go to this slide, yes. So my job today is to provide an overview of PBR for distribution system resiliency, and that will hopefully lay a foundation for the discussions that follow. If we go to the next slide, I'm going to start by defining resilience as the susceptibility of a system to major unplanned service disruptions that are triggered by extraordinary events. This matter of resiliency for distribution systems, like the one in Maryland, is a concern of many US regulators today for several reasons. The risk of severe storms, wildfires, and cyber attacks is mounting. And some utilities have unusually old systems and or chronically poor reliability that makes them more vulnerable to catastrophes. As well, the need for resiliency grows as the economy becomes more digitalized and climate neutral. So this presentation is going to briefly discuss how PBR can encourage better resiliency management. Going to the next slide. So if you're a regulator and you're worried about resiliency, what are some of the issues that present themselves to you? Well, certainly how resilient our utilities are is a lot harder answered than you might think. Also, what is the least cost way to improve the resiliency of our utilities? Is better resiliency worth the incremental cost? A very important question, because resiliency does cost money. How best to fund resiliency improvements? If your utility launches an accelerated campaign to improve resiliency, was the campaign successful? How much did resiliency improve? And was its cost reasonable? Moving to the next. So a lot of tools are available to the regulator to regulate resiliency. They run the gamut from traditional rate cases and prudence reviews to grid planning, to various forms of alternative regulation. For example, cost trackers and the various PBR options. And I'll define a PBR option as a form of alt-reg that uses incentives to encourage better performance. Now, the approach to PBR that most of you are most familiar with at this point is probably the performance metrics and performance incentive mechanisms that are built using metrics, and they can indeed be applied to resilience. But there are other tools as well. For example, revenue decoupling reduces utility resistance to demand-side management, distributed storage, and microgrids, which are all tools to bolster resilience. Another branch of PBR is what I call special incentives for underused inputs and strategies. And in the context of resilience, these could involve, for example, pilot programs and cost trackers for innovative resilience strategies. Then there's the multi-year rate plan approach to PBR, which is the most popular around the world, which strengthens cost containment incentives and reduces the frequency of rate cases. So moving to the next slide. Well, resiliency PIMs are going to be constructed from resiliency metrics. So let's talk a little bit about resiliency metrics. As it turns out, there have been numerous recent studies of this matter, including some taxonomies that sensibly group them into different categories. And I think one of the most useful splits from my point of view is between performance metrics and attribute metrics. Under performance metrics, the salient version would be what sometimes are called the outputs of the system. And when it comes to resilience, this includes things like the number and types of customers that are affected by outages, and also the duration of their outages. When it comes to attribute metrics, you could also group them in different categories. For example, system attributes that affect resiliency, like undergrounding and asset health. And another would be cost-effective methods for achieving resilience through things like the integrated grid planning, and also what are your response protocols or your restoration protocols. So going on to the next slide. Output metrics are traditionally very important in the regulation of reliability. So let's talk a little bit more about that. Resiliency is chiefly a matter of outage duration and prevalence, because there's going to be an outage with a major event. So it's just a question of how big it is. So for that, measures like the SAIDI are pertinent. Now, many of you know that SAIDI is the System Average Interruption Duration Index, which is calculated as the ratio of total customer minutes of interruption to the total number of customers. And where you're all probably familiar with seeing it is in the context of normal reliability, that is to say, reliability under normal operating conditions. And when SAIDI is calculated for that, they're going to remove the so-called major event days, the big storms and what have you. And so that's, when it comes to resiliency, you're talking about the other kind of reliability, that is to say, the reliability under extraordinary conditions. So that could be measured by something like the SAIDI for the major event days. And there's a sort of kissing cousin to that that's mentioned in the literature called a storm SAIDI. It's also worth noting that resiliency is especially important for critical services, like hospitals, or perhaps your favorite hamburger chain. On to the next slide. Now let's talk a little bit about resiliency PIM design, which after all is the topic of this webinar. I'll note first that the need for resiliency PIMs is bolstered if a utility is operating under a multi-year rate plan, which is an increasingly popular approach to alt-reg in the United States. And let's talk then about several potential approaches to the design of resiliency PIMs. And a lot of it has to do with what are the metrics that you're going to use. An obvious focus would be on the outputs. And in theory, this could be a matter of adding a SAIDI for the major event days to the SAIDI for the normal operating conditions. And it would also make sense to look at something like a SAIDI or other duration metrics, particularly for essential services, and those could be itemized into things like hospitals, grocery stores, what have you. So why focus on the outputs? Some of the advantages that are noted in the literature include the fact that outputs are what ultimately matter to the customer and to society. As well, when you focus on the output, you free up the utility to choose cost-effective solutions to the problem. Now, that said, there might be a desire to use reliability PIMs using other metrics. And these could, for example, be a good resiliency management metrics. You could have PIMs for resilient system characteristics like asset health. And you could have them for good O&M practice. For example, you could construct best practice scorecards for grid planning and emergency preparedness, and the list goes on and on of areas where you could score the utility and have some money riding on it. Then there's the idea of a programmatic or program PIM. In principle, you could have utilities awarded for, say, 5% of the estimated net benefits from a resiliency campaign. And if you did that, you would incentivize them to keep the cost down and the impact on resiliency up. Moving to the next slide. Let's talk a little bit more about reliability output PIMs, what they kind of look like. Well, these are actually very common in multi-year rate plans because of the stronger cost containment incentives that those plans entail. And a typical PIM of this sort is going to adjust revenue or earnings to penalize the utility for bad performance using reliability output metrics like SAIDI or SAIFI, its counterpart that has to do with the frequency of outages. So an example of a formula like this, a mechanism, since after all, a PIM involves a mechanism, would be, say, that the revenue adjustment or the earning adjustment is proportional to the difference between the actual SAIDI and the target SAIDI. Now, in reality, these PIMs often have are a little more complicated. For example, they might have a deadband where revenue isn't affected by small SAIDI variances. Going to the next slide. Now, a problem with these output PIMs is that it is difficult to establish good targets for resiliency output since outage duration depends on many external business conditions, some of which are also hard to measure. It's not just a matter of a complex relationship, but even measuring the drivers. And we know about this at Pacific Economics Group because we've developed cost and reliability benchmarking models that we apply to all American utilities, and we've done it for SAIDI under normal operating conditions. And I can tell you that what we've found is that under these normal business conditions, that SAIDI is driven by things like the extent of distribution system overheading, and also by the ruralness and the forestation and the typical weather in the service territory. Now, when you're talking about resiliency, you're adding a whole new layer of complication because you're getting into things like the nature of the event. I mean, it matters whether it's a hurricane, an ice storm, a wildfire, or a cyber attack. The severity is also going to matter. In the case of hurricanes, for example, is it Category 3 or Category 5? And how much of the populated part of the service territory was affected by the storm? Now, reliability also depends on the age and the cost of the distribution system. You wouldn't expect the same kind of resiliency, for example, from an older and less costly system than you would from a newer and more expensive system. Not to say that just throwing money at the problem is a smart idea either. So in conclusion, I would say that PIMs are one implement in a toolkit for regulating resiliency, which also is going to include your traditional prudence reviews, other PBR tools, and certainly grid planning to make sure that the plan to improve resiliency is cost effective. I've explained that resiliency output PIMs are problematic. And that being the case, then what are some practical alternatives that I can recommend to you? Well, one would be basing PIMs on alternative metrics such as attribute metrics. Another would be just relying on resiliency metrics without PIMs, because you don't always have to have PIMs to go along with your metrics. And thirdly, thought should be paid to just establishing duration PIMs with fairly high standards for normal operating conditions, because if a utility is a pretty good duration performance under normal operating conditions, it's going to tend to do better with its resiliency under more severe conditions. Finally, just to say that further research and experimentation is clearly needed on the metrics, the PIMs, we're really just at the beginning of getting serious about how to apply PBR to this challenge.
Thank you, Dr. Lowry. We're now going to hear from David Littell, and I know for this group, David Littell is no stranger, and he's certainly not a stranger to us at the Maryland Commission, where he has been a valued advisor and facilitator for a number of our initiatives. With his law background and his service as a commissioner at the Maine Public Utility Commission, he has consulted with numerous commissions on performance-based regulation through his affiliation with the Regulatory Assistance Project. He recently advised Michigan on developing PIMs for resilience. And as I mentioned, most recently, he helped us in Maryland with our energy storage program. He will share some of his lessons learned with us now. David?
Thank you, Commissioner Richard and Carrie and Commissioner Anthony for convening us here. We can keep going to the next slide. Carrie. What I have to say is going to dovetail with what Dr. Lowry said. And I want to note it is impossible to give a presentation on multi-year rate plans without noting Dr. Lowry's work. Multi-year rate plans are, after all, in most instances, a form of performance-based regulation. We can go to the next slide for efficiency. And they've been around for years. So in a way, a very real way, performance-based regulation isn't new. We're just thinking of using it in different ways. So we're here to talk about resilience. The discussion of resilience itself is new. And so what I want to emphasize in the first several slides, and I'm going to move through quickly, is that it's very critical to establish what type of resiliency you want, what your goal is, and then what the performance criteria is, and then you get to metrics. So only after you have that sorted out, you know that you know how to measure it with the right data and the right formulas, do you really want to start talking about incentives. And then I'm going to talk about what 3 leading states have done in this regard. So next slide. Next slide. It's the header. Okay, performance-based regulation is usually, it's a form of regulation that overlays cost-based regulation. It's not a substitute for it. It's built on very good, competent cost of service regulation. So it's more complicated, not less. Next slide. This is just a metric, I should say, a overview of those states that are looking at different forms of, I think, what we call modern PBR or innovative PBR, taking PBR to the next step. Next slide. And the first step in any good PBR is setting what your overall goal is going to be, what is important. So even for resilience, it's important to talk about what do you mean by resilience? What type of resilience? Because in this area, I think we all know people mean different things, and that can only become apparent once you start to talk about it. Next slide. And then once you know that, then you set up what I call performance criteria. Some people call them targets, which are ideally a mathematical or quantitative way to measure progress towards that goal. Next slide. And after you do that, then you establish one or more metrics, which are your actual formulas to apply to data to measure it. And much too often, people just jump to the metrics and end up with just debating what the metrics are without considering what they really want to get at. Next slide. Just talked about the metrics, so we can go to the next one. And I just put some examples here. Well, this will come out later, so why don't we keep going, since we want to get to the discussion. That's the part. It is important to stop here to emphasize one point that Dr. Lowry made. There are different forms of performance-based regulation, and only one of them, the last one, would attach an incentive to metrics. And just establishing the metrics and making sure you're measuring things properly often can be enough to affect behavior, and that's an important step before you get to metrics. And an in-between stage that some jurisdictions have adopted is to take those metrics and then to rank their utilities. A way we could get at this in the US is to establish the same metric and look at utilities across jurisdictions. There'll be all sorts of arguments that they're not comparative. Those are, those are things that regulators can weigh. In Denmark, they created some competition between the utilities by ranking them on efficiency. Next slide. And this is just a point that this is not just a utility thing. The Department of Defense itself has issued guidelines for metrics and standards for energy resilience at their military installations last year. Next slide. Okay, so a little bit of discussion to the next slide to reemphasize from a slightly different perspective. Next slide, Gary. Resilience, and this definition is consistent with a number of definitions I've seen. Generally, resilience talks about the ability of an energy system or energy operations to minimize service interruptions during extraordinary events or threats. But all of those can be defined differently. So you need to define what you're talking about. Usually there's a sense of robustness against threats and disruption, but then things can break down to go in different directions. Sometimes, particularly when you're talking about the grid, utilities are talking about the ability to recover from disruptions. That can be the case, but sometimes you're talking about the ability to continue operations through the extraordinary event, threats or disruption. So it's really important to distinguish what we're thinking of. And for an example of that might be AMI meters. Many of our commissions have authorized AMI meters. One of the primary reasons we do it is so that you know what's going on during an extraordinary event, so that you have connectivity, so that the communication system stays up, so that even if everything else is down, you know where your outages are. If the system fails, then you are blind, to quote a utility that lost their AMI during a major event, and that can be a real problem. So there are certain operations where the ability to operate even throughout the worst events are ones that exactly what you want to measure. And then lastly, I'll emphasize this. Sometimes resiliency is about the ability to adapt your operations, not return to normal, but to modify the system to continue service. And in the area of climate change, we talk a lot about this. Biological systems often adjust in this way. But I think as we move forward with climate change and distributed resources, we're talking a lot about this without realizing that we're talking about it. The system we're going to end up with, which may have batteries, it may have distributed resources, and having it operate is not the way that our systems operated 5 or 10 years ago. So it's worth ferreting that out. Next slide. That's all to the goal. And then as we're further defining it, you want to talk about whose resilience, from what perspective. And I can't emphasize how important this is, because I find that different people testifying in front of different commissions are making different assumptions as to whose perspective they're measuring things from. There's the customer's abilities to be resilient, and that can differ between residential, commercial, and industrial customers, or even just essential services. Oftentimes, not all the time, people are talking about just maintaining essential services through an outage. There's the ability, forget the customer. Sometimes utilities usually talk about the ability of the grid to recover. And as Dr. Lowry pointed out, you have to talk about what events you want to include and not include, because they'll be different. And lastly, the grid's ability to withstand events, and then defining the types of events. So you're going to talk about just ordinary operations. You're going to talk about all-in measures, meaning the ability to ride through and include storms and major events. Next slide. And what level you're going to do the analysis at, which is different than the perspective. It's really where you're going to focus. So if you're and what you're going to focus on. So if you're residents, are you going to look at resilience through a storm, or are you going to look at resilience with the ability to isolate with a generator or a battery? Are you going to focus on the ability of the military facility to ride through with the grid, or to isolate the way a lot of industrial facilities in my state are designed to do? They can generate and disconnect from the grid their own power, as well as their own thermal electricity. Are you going to be looking at the grid? And if so, what grid? Is it going to be the distribution and transmission grid? Just one of them? Are you going to look at generation, often forced outage rates and generation? Or are you going to look at both of them together? In ICE-PIC that I worked on with Carrie more than 10 years ago, we looked at the whole grid, and that's hard because models are usually designed for production or for transmission and distribution, but not for both. And microgrids are where we're having a lot of this discussion nowadays, because with microgrids, you're somewhere in between the customer and the grid. And what I listed here is just 3 different types of microgrids. This follows roughly the distinction that New Jersey makes in their rules, which I think is sort of a leading example of how to categorize microgrids. Sometimes a microgrid is only designed to operate in a fully connected form. So it'll have different aspects of EVs, batteries, or distributed generation, but it's not designed to island. Sometimes it can be designed to island, but only temporarily. And sometimes a grid can be designed to be independent and only use the power grid itself as in a backup or standby mode. And defining what type of microgrid you're talking about is related to the other issues I talked about before. So you got to figure all that out, what's important, and commissions are doing it, which is what I'm going to talk about next. Next slide. I picked 3 examples simply as examples of states and jurisdictions that I know of that have actually not just dived into resiliency. I think probably almost all of the commissions have delved into some form of resiliency, but these are commissions that have dealt with actually how to measure resiliency and spent the time with staff and stakeholders to answer some of these questions. Next slide. Okay, first up, and we've got staff from at least 2 of these 3 states here, so I'm appropriately humble and willing to be corrected on the descriptions of what these states did. In Minnesota, after a multi-year proceeding with extensive stakeholder input, which is the way to do it, the commission issued an order for Xcel Energy to measure an extensive set of metrics, of which reliability and resilience were a set. Put together, which is not unusual. I bolded here the ones that are usually not associated with reliability, but with more what we think of as one of the very definitions of resilience that we just spoke about. And that would be customers experiencing long interruption durations, customers experiencing multiple interruptions, your average service index, and I bolded equity because a lot of us now are thinking about how these things manifest themselves across different service areas, populations, demographics. And that's an important question to ask. And so we're going to have a very good, this is one of the more extensive sets of reliability and resilience metrics from Xcel Energy reported. Very good data set in the upcoming years as a result of that work group, which was headed up by Kelly Martoni, who was on, if she's still on. So a lot of good work there. Next slide. For Maryland, this is pending in front of the commission, so we're not going to have an extensive discussion here about the pros and cons of it because we don't want our moderator to recuse himself. The battery work group was asked by the commission to clarify and recommend a set of metrics to measure whether the battery pilots, which number 8 now that are approved by the commission, are doing what they're supposed to do. What data are we going to get back from these metrics? Which I can't emphasize enough. When you're authorizing pilots, that's what every commission should do, right? If you're spending ratepayer money to test something, tell the utility exactly how you want to test it. Don't send them off to sort of say, here's a bunch of money, tell us whether this works. And so in this case, the storage work group did as it was ordered to do by the commission, had extensive discussions with the utilities, the stakeholders, the Office of People's Counsel, which is very large and expert in Maryland, and ultimately recommended 80 metrics, which are pending in front of the commission, 2 of which are explicitly resilience metrics. And the work group recognized this distinction between customer resiliency and grid resiliency as being different, and suggested exact measures. This is the text, but there are exact formulas that were recommended as well. And first, for customer resilience, only for the pilots that had behind the meter batteries, which is not all of them, they wanted a measure of the minutes of energy that were provided when the grid went down in islanding mode. So it's 1, maybe 2 of the pilots now. There was 1, I think, one of the 2 new ones that was approved for Potomac may have behind the meters. We're going to actually find out when the grid goes down, are these providing island capacity? Green Mountain Power actually authorizes batteries to do just that. So, I mean, but, you know, I don't know if they have good metrics to measure them. They might, I just don't know that. And I think there's someone on from Vermont who can answer that question. Next, for grid resiliency, we wanted the utilities to quantify how energy storage actually kept the grid operating and to report on its ability to restore service on those feeders or the entire grid after a major outage event. So that's that. Next slide. And the group also recommended that these traditional measures of reliability be reported with no event exclusions. So this would be without a major event exclusion, or all in, as some people call it, for these 3 system measures that are noted here, and as well as MAFI. And this is important at the local level, that these should be computed on the feeders that are affected by the energy storage installation, right? We wanted to see if locally these batteries are making an impact, realizing that from a system-wide perspective, we're probably not going to be seeing an impact. So let's measure it locally. Dived into the level at which we wanted to do the measurement. And so we'll see what the Maryland Commission does for this. Next slide. And lastly, this is still at the point in North Carolina of the stakeholder groups. There's their Department of Environmental Quality convened a group to look at a series of energy-related outcomes. And for resilience, they came up with these very specific recommendations of preferred metrics. With some participation from their energy office. And the report I had was that their commission actually didn't have staff on this subgroup, but nothing's been adopted yet, but it's still worth talking about it, because a lot of stakeholders in North Carolina have thought of this. And in this case, they chose to emphasize resilience of critical assets, including military, but critical assets being hospitals, those types of facilities. So went in for a different sort of definition of resilience. But their alternative metric talked about all customer homes, right? So whether this goes forward in North Carolina, we will see. 3 examples of forward thinking. So with that, next slide, I will just point you back to the earlier presentation of your last session. Joe Ito presented from the Berkeley lab some other metrics to think about. And what's helpful here, I think, is that he also said, look, this is the data you need to measure it. And when you're thinking PBR, you always have to ask that question, right? Do we have the data? Do we have a good data set now to measure it? If so, you can actually do analysis looking backwards. If you're going to have to establish a new data set and apply it to the new metric, you probably don't want to be attaching any incentive to it yet, because you don't even know where to set it, right? You don't have a good baseline. So with that, I look forward to the discussion with all of you, and I look forward to our next presentation from Puerto Rico, where my colleagues from RAP have done work, but I have not, so I want to learn something.
Thank you, David. That was a very nice presentation, and you represented Maryland's program very well. Thank you. We're next going to hear from Commissioner Matteo Santos. Commissioner Matteo Santos is coming up on her 3-year anniversary of being a commissioner, and she also has a law background. Puerto Rico has been dealing with very unique issues, and Commissioner Matteo Santos agreed to join us to share how they have been approaching resilience, metric development, and performance incentive mechanisms for resilience. Commissioner.
Thank you, Commissioner Richard. Thank you tonight for inviting me. And the previous presentations have been great. I hope that mine provides more information to all the participants. Our experience is very unique because we are working on resiliency in the aftermath of the hurricanes that took place in 2017 that really affected our electric system and almost destroyed it. So I wanted to give you, next slide, Carrie, please, some context so you could understand how is our system and the utility we have. We have a main utility. It's a public government entity and was created in 1941. We have 1.48 million customers, a significant amount of customers per square mile, a lot of cables at the level of distribution and transmission, as well as substations. So it's a very complex, isolated island system. We are not interconnected to any other utility or any other source. And our generation fleet, PREPA's generation fleet, is very old, and not a lot of resources have been allocated throughout the years to the modernization of the grid. So we are dealing from a standpoint to achieve resiliency. We are dealing from a position that it's not the same as other jurisdictions, and it's a very big leap what we are facing. In order for put resiliency into public policy, our main legislation was modified. Next slide, Carrie. One of the big transformations that it also impacts resiliency to a certain extent is that in 2018, the legislature decided to break the vertically aligned monopoly of PREPA, and the legislators decided that PREPA would retain the assets of the generation until it divests generation to private entities, third parties, through PPOAs, and the T&D is going to be operated and maintained by a third party, a company that was chosen last year on June. They entered an agreement under which PREPA retains the ownership of the T&D, but transferred the operation for a period of 15 years. And under the contract, there is a fixed fee for those operation and maintenance responsibilities, as well as the ability for receiving a bonus. And that's where the bonus takes place. Next slide. Under Act 57, which created the Energy Bureau, we have been empowered to adopt regulations, and we were required more recently through an amendment in 2019 to adopt regulations before December 31st, 2019, establishing mechanisms for performance-based regulation. And amongst the list of mechanisms, which is very similar to the one in Hawaii, we can establish performance metrics. So the Energy Bureau approved the regulation, next slide, on December 2nd, 2019, we adopted the regulation. The regulation establishes a process through which we would open a docket, and in that process, which is an adjudicative one, we would establish specific targets for that entity, and compliance with those targets would be, in this case, LUMA would be accompanied either by an incentive, a percentage of the bonus, or a penalty which would mean not receiving that bonus. And in order to gather information, next slide, the Energy Bureau had already started some gathering efforts with PREPA, and we established probably more than around 100 metrics or parameters for which we wanted reporting from the utility in order to, under this docket number that you're watching in this slide, establish some baselines and benchmarks. For the benchmarks, we looked around plenty of utilities that share similarities with Puerto Rico, either because of the size of the customer, the weather events that they experience, and the type of utility was public or investor owned, etc. So we have a fairly diverse but comparable mix of utilities. And based on that, we recently issued a resolution establishing a baseline, a list of baselines, which is where PREPA is, which is not a very good situation in terms of many of the metrics, and where the system or where compliance should be. And those baselines and metrics are going to be used in the establishment of the PIMs. Next slide, please. Under this docket number, LUMA, the T&D operator, filed for approval of PIMs. These PIMs are going to be used for the bonus that they are allowed or eligible to receive under the contract. And in that process, we will have to decide the parameters for which penalties or incentives are going to be assessed, the weight that each one is going to have until we reach the bonus limit maximum under the contract. And some of those will have to do with resiliency, obviously. And there are other proceedings in which the Energy Bureau is also looking into things regarding resiliency. For example, in the recent IRP that we finalized in 2020, we decided that the construct or structure under which PREPA was proposing to achieve resiliency was not optimized, and therefore we had to go into an optimization proceeding that is ongoing now. And there we're trying to decide what is the best mix of investments at the distribution and transmission level in a concept of mini grids, which would be operating under extreme circumstances. It's not going to be the day-to-day or steady operation, but would give the grid the ability to disconnect certain regions while the others can continue to have power. So we would like to avoid an island-wide outage like it happened during the year after the hurricanes. That process is also taking place. We also, as part of a result of the National Neighborhood Planning Initiative, we are also working on another docket on the distribution planning initiatives. In that docket, we're trying to modernize and check what investments are being done in the distribution system so it is properly modernized and make more resilient. Next slide. There's a lot of challenges, and particularly for us that we experienced such a bad situation after the hurricanes, resiliency is very important and very upfront subject for everybody. But there are a lot of difficulties to reach proficiency in terms of establishing metrics in this area. It's not, first of all, I don't think that there is a silver bullet or a panacea for these issues. So I think that we may end up more likely than not with a diverse group of different ways or metrics to try to incentivize resiliency rather than a single solution. Nonetheless, all the solutions or the ways to strive through, towards resiliency should try to benefit the most, the largest amount of customers possible. So we are not only benefiting certain areas or classes of customers or economic sectors. One of the things that everybody seems to agree is that gold plating should be avoided at all costs, because as much as everyone would like not to go through what happened after the hurricanes, there is no way to bulletproof the system in a manner that would not sustain any damage and that would be cost effective to ratepayers. So that's another thing that it must be taken into consideration. There is not exact science as of today for simple solutions in terms of finding these metrics. So we are taking initial steps, and I am sure that there will be room for improvement and for evolution in the subject, but it is very likely that we can find through a lot of the other metrics, indicators, or indirect ways to measure resiliency, even in qualitative or quantitative ways. And with that, I mean that, for example, we have a very large issue with vegetation management. Vegetation management, although it's sometimes looked as a very operational issue, it also has a very significant impact on resiliency. A hardening of the system through the use of federal funds that are available through FEMA is going to be another important subject that would help, if properly used, help harden the system so it sustains less damage and is able to be restored quicker than before. Preparedness for responses in the emergency scenarios, as well as preparedness for cybersecurity, are going to be very important. AMI and other softwares and technology that would allow us to have the visibility that we don't have today are also ways that we may directly or indirectly be dealing with resiliency, and in the process of finding what would be the perfect ways, we at least are gonna take a path through the good ones until we reach the better ones. Thank you very much.